This video we're going to look at how to solve simultaneous equations using some examples from chapter 3. The first method is by the method of substitution. So we're going to look at the first question here. We've got a pair of equations 3x plus y equals 5 and x minus 2y equals minus 3. First we establish that a solution exists. We do that by calculating the gradient for each of the equations. So for the first equation we have 3 delta x plus delta y equals 0, which solves to give us delta y over delta x equals minus 3. The second equation, we've got delta x minus 2 delta y equals 0, and that gives us a gradient delta y over delta x, which is equal to a half. So the gradients are not equal, therefore we know that a unique solution exists. Now let's use the method of substitution. We've already got an equation for x, so we've got x equals 2y minus 3. We can substitute that into the first equation to give us 6y minus 9 plus y is equal to 5. Now rearranging that, we'll get 7y is equal to 14, and therefore y is equal to 2. Now we can substitute that back into either of the equations. So in this case we'll just use the second equation, so we'll get x equals 4 minus 3, or x equals 1, and that gives us a solution of the form xy equals 1, 2. So that's how we use the method of substitution to solve a pair of simultaneous equations. Now an alternative method is the method of elimination. And we're going to use an example from question 4 here, and we're going to take the part D here and use the method of elimination. So we've got x plus 3y equals 3 and 2x minus 9y equals 1. So again we're just going to establish that a solution exists by calculating the gradients. So for the first equation we've got delta y over delta x equals minus a third, and for the second equation we've got 2 delta x minus 9 delta y equals 0. That gives us gradient delta y over delta x is equal to 2 over 9. So again the gradients are not equal, so we know a unique solution exists. Now we've got to transform one of the equations so that we can eliminate one of the variables from it. So we're going to multiply through by 3 in the first equation to give us 3x plus 9y equals 9. And then from the second equation we've got 2x minus 9y equals 1. So we can add those two equations together to give us 5x equals 10, which solves easily to give us x equals 2. And again we can now substitute back into either of the other two equations. So for example we can write 2 plus 3y equals 3 from the first equation, and therefore 3y is equal to 1, or y equals a third. So our solution here is xy is equal to 2 and 1/3. And those are examples of how to solve these types of equations.